So on my website, reflectionsofadatascientist.com, which preceded these videos, k-means clustering in SPSS is probably one of the most popular topics, at least according to Google Analytics. So I thought, well, let me bring this knowledge to YouTube as well. So hopefully all of you can benefit from it also. So in this video today, we're going to be doing k-means clustering, and we're going to be doing it in SPSS. And not only will we be discussing k-means clustering, but I'll also show you how to graph your findings and also how to scale your data using the Z-Score normalization. All of the data that you see here can be found in the video description. It's in CSV format, so you'll have to go ahead and format that before importing it. But if you want to follow along at home, that gives you a great opportunity to do such. So let's get started. And with anything, any of these exotic methodologies or methodologies which are a bit more so off the beaten path, make sure that you describe every step to the best of your ability in your methods section of your research. So we'll begin by rescaling our data through the Z-score normalization process. So think of this. Let me just sort of explain this concept prior to doing such. Think of these as individuals of some sort. All right, so each ID represents a unique individual. And these are categorical observations as it relates to this particular individual. And these are continuous variable observations as it relates to this particular individual. And what we want to do is we want to group these individuals based on characteristics which are found within continuous variable 1, continuous variable 2, and continuous variable 3. So we want to generally place each one of these individuals into a different category or a different cluster, as it were, based on scores from each one of these variables. So again, we're going to begin with a Z-score normalization process. How do we do this? Well, what we're going to do is we're going to go to Analyze. We're then going to go to Descriptive Statistics, and we're going to select Descriptives. Now, as you can see here, I was playing around with this a bit prior, but this is what it'll look like when you load it up. We need to move the variables which we're interested in rescaling to the right. So we're interested in variable 1, 2, and 3. The continuous variables, categorical, we'll leave alone. As far as options are concerned, you can just leave all of the default options as they are, style and bootstrap as well. But it's important that you make sure that this particular box here is checked, which is save standardized values as variables. And what this is going to do is it's going to create an additional column in our data set here once this particular methodology is applied. All right, so let's go ahead and click OK. So what we have here in our output window is we have the number of observations for each continuous variable. There were 35 observations in each, and that's convar 1, convar 2, convar 3. This was the minimum value as far as observations are concerned in each variable. The maximum for each variable, the mean of each variable, and the standard deviation of each variable. All right. So mean, standard deviation, minimum, maximum, mean, standard deviation, minimum, maximum, mean, standard deviation, minimum, maximum. But what have we here? What are these new values which were added? Well, what we have is if this data was combined and we were assuming that each variable, convar 1, convar 2, and convar 3, but just thinking on convar 1 for the time being, we'll assume that this data adheres to a normal distribution. Well, if this data, when combined, is normally distributed, what would the Z-score be of each individual observation within the combined set? So the Z-score, assuming that convar 1 is normally distributed of 97, is negative 0.58774. The Z-score for 133 for convar 1, assuming that the data is normally distributed, is 0.26347. And the same goes for convar 2. So assuming that this data is normally distributed, the Z-score for 297 is 1.38633. And that goes for each of these variables here. These are the variables, and these are the observations contained where therein. These are their corresponding Z-scores. Okay, so with that, and make sure you note that you performed this particular step in your method section. With that, we can now perform our k-means cluster application. Now, k-means cluster is not exclusive to SPSS. There's different methodologies of application which apply to each particular platform. So MATLAB has its own way of doing it. SAS has its own way. R has its own way. SPSS has its own way, and each way is proprietary, except for maybe R, because with R, it's by the nature of the software, you can see the algorithm which is being applied. You should end up with answers which are the same or just about the same as it pertains to the output, but just make sure in your method section you list which platform you're utilizing to perform this method application. So anyone who wants to check your results or audit your results can come to the same findings. So let's begin. We want to go to Analyze, then we're going to select Classify, then we're going to select K-means cluster, and we have to specify our variables. So we have our Z-score normalized variables, so we're going to select those. There's 3 of them. We're going to place them over here. And we have to select how many clusters we want. Now, what's a cluster? A cluster is the number of groups that we want to categorize this variable by, our ID variable. So we want to categorize, place into categories based on the k-means cluster analysis, each one of our unique variable row combinations. Okay, so we only want to create 2 categories. So that's the number of clusters. If we wanted 5 categories, that would be 5. If we wanted 7, it would be 7. We're going to just do 2 in this instance because it's a relatively simple example. Make sure you select Save over here prior to proceeding. You want to make sure cluster membership is checked. If not so already, make sure distance from center cluster is checked. And once that's done, click Continue, and then click OK. So we're going to have some additional information placed into our output window. What we're really interested in, and at least initially, you can just ignore initial cluster centers. We're interested in the iteration history. Now, the iteration history is how many. Actually, let me just read off of my notes here because I don't want to create any confusion. So iteration history is important as it is utilized to determine the strength of the model. The k-means method requires that the user select the number of clusters to be included within the analysis. Remember, we chose 2 clusters. That's how many categories we'd like to create. Therefore, finding the appropriate number of clusters to include as it pertains to the quality of model requires some repetition on the part of the algorithm. What iteration history illustrates is the number of algorithmic iterations that were utilized in reaching the value of 0 for both center clusters. So in this case, the current iteration is 5. Okay, so 5 iterations were utilized. There can be instances in which 10 iterations are attempted and not a single cluster will reach a value of 0. To build the strongest model possible, a user must create multiple models with the same data set, changing only the number of clusters. So you want to make sure when you're creating these, when you're selecting clusters, that the number of iterations reaches 0 prior to reaching 10. So in this case, we only had 5 iterations, so we're good. The model output, which contains the smallest number of iterations needed to reach 0, should be finally implemented by the user. So we could keep playing around with, number of clusters to see which can reach 0 the fastest as it relates to iteration. But we're going to be dead set on 2 clusters in this instance, so we're just going to leave it at 2 clusters. All right. Now, I want to do a little bit of graphing here. So what we have here is the number of cases in each cluster. So 16 cases, 16 IDs could be placed in cluster 1 based on the three variables which we created, the three Z-score normalized continuous variables. And 19 individuals could be placed into cluster 2. Again, that's based on the same variables which we created through the normalization process. But just to take a kind of a better look as to what's going on here, double click on Final Cluster Center. This submenu here should pop out. Make sure you select the values for the clusters, right click, choose Create Graph, and choose Bar. I'll close out of here. Now, what you're going to get is this particular output. And what this is illustrating is this is showing these bars. This is referring to the average value of each variable within each cluster category. So the average value of each variable in each cluster category. So for the Z-score cont_var1, the average value is represented by this bar. So if an individual was placed, and what this is will make more sense when we look at our data again. If an individual was placed into cluster 1, the average Z-score variable value is this variable here. If they were in cluster 2, that variable mean is here. If they were placed into cluster 1, the variable Z-score cont2, the average is this. If they're placed in cluster 2, the Z-score mean is here. All right, so let's get out of here. Now, what you see as being created, we're just going to zap this. There we are. This right here is the cluster based on these values that our k-means cluster methodology placed our variables in as it relates to cont_var1, cont_var2, and cont_var3. So we're going to sort this by ascending. So as you can see, these individuals, ID 5, 6, 8, 10, so on and so forth, based on these values here, cont_var1, cont_var2, cont_var3, were placed in cluster 1. So cluster 1 is a category. Now, as it relates to these individuals here, based on their scores, Z-cont1, var1, Z-cont_var2, Z-cont_var3, they were placed into categorical cluster 2. And as we were looking at our graphic previously, the mean value of Z-cont_var3, if we were to get the mean of these values together that I highlighted, that is right here because they're in cluster 2 and it's the mean of cont_var3. And if we were to look at the mean value of cont_var3 as it relates to all of the individuals placed into cluster 1, well, that value is graphed over here. Now, because these are perfectly inversed on the graphic, we're going to assume that the model is providing significant results as it relates to the clustering. So now what we want to do is we want to graph this data. All right, so how do we do this? What we're going to do is we're interested in graphing the data based on which cluster an individual was placed in based on these continuous variable values. So let's go to Graphs. We're going to select Chart Builder and just click OK if this dialog box appears. And as you can see, I was already playing around with this, but we'll reset it. You want to be sure that you select from this particular gallery tab, scatter/dot. We're going to choose a scatter plot graph, and we're going to drag it up here. Now we have to select the x-axis and the y-axis. All right. So I want to have our clusters graphed as predicated upon the categorical values, which were not included in our k-means clustering. So we want to see where these IDs, these individuals, as far as the clusters are concerned, where those cluster values fell as it relates to the value of categorical variable 1 and categorical variable 2. So we're going to place categorical variable 1 on our y-axis, categorical variable 2 as our x-axis. And now as it relates to coloring, we're going to want to make that the cluster ID number. So we're going to just place this here. And then we're going to click OK. Now this might take a moment or two to actually perform the graphing process. So let's go ahead and click OK. And looks like in this instance, we had instantaneous results. So here is our output. Now, obviously, this isn't the prettiest of clustering graphics. If you wanted to change the color, you could double click on this, which creates a sub menu, and then you can play around with the color type if you so choose. If that was something you were interested in doing, maybe you wanted to make this color red instead of green. But ideally, if you had a greater number of dots and a differing access values, you might end up with prettier clusters. As you can see here, ours is a bit of a mess. But in any event, a perfect clustering or a prettier version of our output would look something like that. This is from the Wikipedia article, so obviously it's a best case scenario. So that is how you perform the graphing function, the k-means clustering methodology application, and the Z-score normalization process within SPSS. And that's where we're going to end today. So if you enjoyed this video, please consider liking and subscribing. If you have any questions, maybe leave a comment so we can help one another out. We're trying to get this message out to as many users as possible. So best of luck in your research. Thanks for stopping by. And until next time, take care.